Be our last session in Unit 5, then we'll move on to Unit 6. We actually have finished everything we needed to do in the notebook. However, I felt I would be remiss if I didn't point out at least a single application of civil engineering. The Roxwald book that you've been using for extra problems when you stay with a topic more than one class. This book has a lot of civil engineering problems in it, so I picked out one that I wanted to do with you. Oh yes, it's a little bit backwards today. These are the homework problems that we will do in class when we meet next. And here's a problem right out of Roxwald. I forget what number it is in the book. Doesn't matter, I guess. Highway curves. How do they plan how they're going to design a road? The figure below represents a circular curve from here to here. We see 90 degrees, I believe. I mean, it looks like. It doesn't. I better not assume that. Well, this is 90 degrees. Yes, it is a 90 degree central angle. Circular curve with radius r. Where's that radius? Well, if this is the vertex, this is the radius right there and there. The tangent length. Now, we haven't talked about tangent at all, but you did learn this in geometry, didn't you? That the tangent line to a circle is the line that only touches one point of the circle, and it is always perpendicular to the radius of the circle. So how can we show what t is equal to? Let's think what the tangent of this half angle would be. So we're looking at this angle here, which is part of a right triangle. There. So we don't worry about the hypotenuse in the case of tangent, do we? We are only looking at the opposite, which is t, divided by the adjacent, which is r. So this is pretty easy to do, isn't it? T, therefore, is going to be equal to r times the tangent of the half angle. So not only is it a useful measurement to have, it's also easy to calculate. Find t for a curve with a radius of 1,500 feet and a central angle of 80 degrees, which means the half angle will be equal to 40 degrees. Tangent of 40 degrees. We need our calculator here, don't we? We need our calculator here for 40 degrees. First of all, let's check our mode. Seems like forever since we've used calculator. Okay, so we put it in degree mode. Now we'll find tangent of 40 degrees. Okay, 0.8391 we would say. 0.8391. Remember, we always go out 4 decimal places with any of these trig functions. So my t is equal to 1500 times this number. So let's go ahead and see what that is. I've got it right here on my calculator. Times 1500 feet. So my answer is going to be in feet. 1256.65. I don't think we'd have to be that accurate, but 1258.65 feet. It's important to put that measurement in there, isn't it? And that's exactly what we got. Well, if we had rounded to the 10th place, it would have been 0.6, just as we have there. Here are all your sum and difference identities, your cofunction identities, your double angle identities, your power reducing identities, your half angle identities. By the way, did that throw you off a little bit, seeing half angle here and thinking of your half angle identities? Sorry about that if that happened, because in this case we didn't even have to use any half angle identities. Okay, I'm going to see you back in class, and we'll go through the homework problems in your workbook 11 and 14.